Part C. We have 2z divided by z minus 1 minus 3z divided by z plus 1. Okay, look at the denominators. Do they contain any common factors? A lot of people would say yes, z minus 1 and z plus 1 have common factors. The answer is no. Z minus 1 you have to look at as one quantity. So the division bar is a grouping symbol, and it groups this whole denominator together. Likewise here. Z minus 1 is one quantity. Z plus 1 is one quantity. Do they have any factors in common? Not that we know of, no. Okay, how do you find an LCD? Like, okay, let me show you a numerical example. This is the one that your son or daughter is going to come up to you and ask you in 10 years, Mommy or Daddy, how do I add 1/2 plus 2/3? And you can't say to your son or daughter, well, you pull out your calculator and you hit the fraction button. No, that's not, I mean, that might be true, but and you could do that to check your work, but no, you got to know how to do this. So you need a common denominator, right? What's the common denominator of 2 and 3? 6. Since they don't have any common factors, 2 and 3 don't have any common factors, you just multiply them together to get the LCD, right? So 2 and 3, no common factors, so the LCD is 2 times 3, which equals 6. Okay, now back to part C. Z minus 1 and Z plus 1 have no common factors that we can recognize, so what do we do to get the LCD? We just multiply them. So let me erase this and point out then that the LCD of the two denominators is just going to be the product of the two denominators. Z minus 1 times Z plus 1. Does everybody understand? When they don't have any common factors, just multiply to get the LCD. Yes?
I was thinking you could do -1 multiplied by the Z minus 1.
So if you factor out, so if you have Z minus 1 and you factor out a -1, you end up with negative Z plus 1, which does not look like that, right? It's a good idea, but no, it's not going to work. They don't have any common factors, okay? So here's what the confusion is with a lot of students. So you're confusing that with something like A minus B and B minus A, right? We're not turning the operations around, right? So these guys are opposites of each other. But Z minus 1 and Z plus 1, they're not opposites of each other. It's not of this form, A minus B and B minus A. Okay. So what we do then is the same process as before. We take this first guy, 2Z divided by Z minus 1, and we multiply numerator and denominator by the factor that guy is missing from the LCD. Let me say that a little better. We multiply the numerator and denominator by the factor that's missing from the LCD. You have Z minus 1. Which of these two factors is missing? Z plus 1. Okay. So we're going to multiply numerator and denominator by the factor that's missing, Z plus 1. We're multiplying by Z plus 1 over Z plus 1, which is really equal to 1. We're multiplying by 1, so we don't change the value. Now, when you multiply, it's a good idea, and you have quantities, it's a good idea to start putting in the parentheses that are supposed to be there. They're implied anyway by the division operation. The division bar implies those parentheses are there. Okay, and then the second guy, we have minus 3Z over Z plus 1. So you look at this denominator. What is it missing? What is this guy missing from the LCD? What factor? So the denominator is Z plus 1. Which of these two guys is missing? Z minus 1. Okay, so what you do is you multiply numerator and denominator. I'll go ahead and throw in the set of parentheses here, by the factor that's missing from the LCD to get it in terms of the LCD. And you're really multiplying by a big old 1 when you multiply by Z minus 1 over Z minus 1. It's really the same process as before, isn't it? The process doesn't change. The rules don't change. Our perception of it might make it look different, but it's really the same process. Okay, so think about it then. If I wanted to make one fraction out of this mess, I could just right now, if I wanted to, even without doing the multiplication, or I could just write down the multiplication. Okay, I could write that down as one term in the numerator. Okay, so if I wanted to write this as one big fraction right now, let me show you how you could do that. Whoops. Let me try and draw a straight division bar. One big division bar, that's as straight as I can get. The common denominator is z minus 1 times z plus 1 or z plus 1 times z minus 1, doesn't matter. The order of multiplication does not matter. So there's the common denominator that we came up with. And the term we get from this guy is 2z times the quantity z plus 1. So that's the left-hand numerator. And we're going to subtract the right-hand numerator. Now, notice I haven't distributed yet, because I wanted to make a point here about that distribution. So we're not done. And don't try to start canceling. That's the dark side. Why can you not do this? So the thing that will give me an early death is students that do this. I'm going to start canceling. Yay, woohoo! It's a rodeo. Why can't you do that? The operation on top is not all multiplication. Can't do it. Okay, so stop that. Hopefully you didn't copy that down, because it's totally wrong. And it drives algebra teachers crazy. But students do it all the time. It's the most common mistake there is. So if you make that mistake, don't feel bad about yourself. Just try not to make that mistake, or try to correct it if you do make it. So what can I do? I can multiply out the numerator. Don't multiply out the denominator. There's no reason to. Multiply out the numerator, combine like terms. Okay, to simplify it. So that's what we'll do. Let me get a little more room here. So a little more room, and then if I distribute the 2z in the first grouping, what do I get? 2z squared plus 2z. If I distribute the minus 3z, what do I get? Minus 3z squared. Okay, you're distributing a minus over a minus, makes plus 3z, doesn't it? Now don't forget, this is just the numerator, so the denominator doesn't change. Z minus 1, z plus 1. Okay, double check. 2z squared plus 2z, and then minus 3z squared plus 3z. Any questions on that? Yes?
So would it be incorrect to take the denominator and have to FOIL it out and have it be z squared minus 1?
It would not be incorrect, but there's no reason to do it. And here's the thing. If you end up this can happen. In the numerator, you might end up with a factor. Once you simplify and factor it, you might end up with a factor of z minus 1 and a factor of z plus 1, which would divide out. So you don't want to do that. You really don't want to. It might not hurt anything, but you might not recognize how it simplifies if you multiply out the denominator. Okay, so now combine like terms in the numerator. So I see a 2z squared and a minus 3z squared. What does that make? Minus z squared. So I took care of that guy and that guy. And then what else? 2z and 3z added together make 5z. And then in the denominator, z minus 1, z plus 1, or other way around. Now in this case, okay, yeah, the numerator has a factor of what that you could factor out? Z. But is there a factor of z in the denominator? No. So it doesn't simplify, so I'm not going to bother factoring the numerator. You could, it's not wrong, but there's no reason to do it because it's not going to divide out with anything. So I'm going to stop there. You could, by the way, you could write the numerator as 5z minus z squared. Some people like that aesthetically better. It doesn't matter.